Okay, I hope all team members are back. Again, the recording is started. So, what happened? If you want to inspect till application layer, suppose you want to inspect the Word file or email attachment. So, legacy firewall features will not support for that type of inspection. Okay, so firepower kind of engine, IPS engine, is known as SNOT. Okay, so firepower IPS. Okay, somebody is asking some question. So,
नहीं मैं बता रहा हूँ क्यों दे रहा हूँ
I'm sorry, Sundar. Can you please come again?
No, I'm not asking any questions.
Sorry.
Just unmuting.
Okay. No problem. So this IPS engine is known as SNOT, and for URL filtering, it needs to add WSA appliance. So here, one legacy firewall. I'm deleting this. Okay. So one legacy firewall, you will have, for example, ASA. Okay, and if you want to use the traffic, for layer 7 infection, you have again another installed another module. What is the name of that module? Firepower FP. Now writing in short, FP. Okay, and for URL filtering, you need the WSA appliance. Okay, and if you want to protect this for infections or for virus and attacks, just like malware protection, so you will have to use the AMP engine. AMP engine for vulnerability and malware protection. Okay, and again another spyware or your vulnerability protection or complete antivirus package, you have to use the UTM, Unified Threat Management System. Okay, and for that WSA or URL filtering, that is called the CX protection. So all these things are enabled here, just like here CX protection is enabled. Let's assume on top of your network, this legacy firewall 1, 2, 3, 4, 5. Let's assume there are 5 separate devices are installed, and think about that packet, but we were discussing in our routing packet flow. It was taking around 800 seconds. This is only the example. Okay, it may be the millisecond or less. Okay, but in this situation, the packet will go in each and every device. Each and every device will process this packet. So think and imagine how much time it will take and how it secures. Okay, definitely it will take much time. Okay, but in next generation firewall like Palo Alto, Fortinet, Checkpoint, Cisco FTD, they provides these things in, I mean, they combined all the things in one firewall. Okay, so that is called NGFW, next generation firewall. Okay, so one single device is providing the features of all these features. Okay, but Palo Alto firewall does provide more than it. That's why it is very popular. It provides the app ID protection, antivirus protection, spyware protection, URL filtering, vulnerability protection, and wildfire protection, data protection. Okay, and it all each and every next generation firewall. It inspect traffic based on the L3, based on the L4, based on the layer 7 raw data. So it can protect traffic basis on the L3, L4, and L7 information. L3, L4, and L7. But in legacy, L3 and L4. Okay. So there are some next generation firewalls in the market, just like Palo Alto. So Palo Alto firewall, it comes with its firewall manager. The manager name is Panorama. PA, Palo Alto and Panorama. Okay, Fortinet, it comes with Forti manager. Checkpoint security management server. Cisco FTD, the management server name is Cisco FMC. These are the models and brands which are here in the market. So what happens in stateful inspection? Let's see. Okay, so in stateful inspection, what happens? It will check the layer 3 and the layer 4 information within an IP packet and store that information in a separate table referred as a session table of the OSI model as a state table of the firewall. So in some firewalls, it is called the state table, and some firewalls, it is called the session table. You will get the session information at the GUI also and the CLI also. All traffic flows through the firewall will be compared, inspected against state table. Okay, so if you will assume here the router, the PC, and I'm sorry, here in place of router, this is the firewall. Okay, and this is the server, this is the PC. So once first request will hit on the firewall ingress interface. So it is the send packet, send request. It is the send request. Okay. So it will inspect this entire packet and make the session table, and it will make the entry in the session table or of that particular packet. It will have the information all about the checks and parameters, but we spoke our routing process. Same thing it will happen here with the firewall, but firewall will make the entry of this send packet request, and it will after processing it will forward this packet to the server. Once it will receive back this packet to the firewall, it will check this entry, source port, destination ports, all the things. So if it is matching with session table, firewall will understand this this is the session table. I mean, this packet has the entry in the session table. So firewall will process without checking any parameter. Only it will reject the errors and it will process the packet. So it will not consume the time. So it maintains the state of connection when packets traveling for the appliance. A stateful firewall maintain the state of connection in the state table of firewall. Okay, so when it receives reply packet, it match the packet information to state table. If firewall receive the reply packet, and if that packet it will match, then packet will be accepted, otherwise firewall will drop the packet. So every time it will see the session table first. We will discuss this in firewall flow logic. Okay, so suppose here first packet is hitting on the firewall. So first packet is taking 2 seconds. Okay, so we are sending the 20 GB traffic. 200 packet will go and the 200 packet will back. Total 400. Now how much time it will take? Only first packet it will take for 2 seconds. Except each and every packet will take 1 second. It will take only 1 second to check the session table entry and process the packet and forward to towards the egress interface. So total it will take 401 seconds. Okay, now suppose there is a firewall in place of router, let's say Palo Alto firewall, or so flow logic of the next generation firewall, what it will happen, what we spoke here. So you can check here, initial packet processing, it will check the source zone, address, and then user ID, policy based forwarding lookup, let's say destination zone. Okay, so suppose your firewall having the two interface, one interface belong to inside zone and one interface belong to outside zone. Okay, so suppose at outside zone it is receiving this packet. So this is the source zone outside and destination zone inside. Okay, so it will check the destination zone and then it will check the net policy. Okay, so source IP address, source port, destination IP address, destination port are there in that packet or not. Accordingly, it will go with the netting. Okay, if it is this first line is okay, then it will go to the second line, security policy and allowed ports and a session created. After that, it will create the session. Okay, so whatever, if you will see the dashboard or in router, it will show access list. In Cisco firewall, I think so ACL or so access list also there. There are different commands. So if you will show the configured access lists, whatever is configured in the router or firewall, so it will display the ACLs. But here, in case of the firewall or next generation firewall, it will check the configured access control list. It will have the source port, destination port, and source IP, destination IP, both sides. And at last, there will be the comment, I mean parameter, allow, deny, or drop. There may be multiple instructions to process the packet. And according to that ACL, configured ACL, it will process the packet. Okay, so after that, session will create. It will create the session table. If there is no entry in the session table, it will create the session entry. Okay, so it will have the entry in the session table After that, it will go to the application layer. So what happened with the application layer? It will check the traffic is encrypted or not. Okay, decryption policy. Of course, if packet is encrypted, then it should be decrypted also. Okay, and override policy, application override policy, and then application ID. What is the application ID? What is the app ID? We will discuss later once we will come on this topic. This is very important here in next generation. After that, it will apply and check the security policy and apply accordingly. Okay, profiles. In short, I will say, if you have blocked the job portals in your organization, just like Naukri.com or founded.com or any other job portal. So there is a category in internet. Suppose the portal belongs to the job category. In that situation, if your organization have the policy for particular team, and that team cannot access the job portal from that particular organization, and whatever the data is coming on the firewall interface, ingress interface, that is outside interface, so it will check that category, and the security profile is applied to block the job portals, and this data is matching with job, it will drop the packet immediately or reject that. Okay, if it is not rejecting, category is pass. Suppose the category is medical or medicine, it will allow, because your organization has allowed to each and every user, and each and every user can access the medicines medicines category portals. So after that, if it is passed, packet will go in post policy processing and re-encrypt the traffic, apply the net policy, and forward to egress interface. Guys, this is very important. Packet flow is very important. If you have any question about the packet flow, just tell me. Else I will assume you understood the packet flow. Okay, any question? Or should I go move? Okay.
Is this sequential or it happens, in parallel, all these flows?
See, don't go. I think you are thinking about the SP3 architecture, right?
Yes.
Yeah.
Is it same for all, like Cisco and Alto firewall?
If you are comparing with SP3 architecture, we will discuss that part later. Okay, SP3 is the different thing, but the packet flow is almost similar in all the firewalls. 1 minute, I'm opening the packet flow of the ASA for your understanding. If you will understand that thing, that will be good for you all. Okay, this is the ASA firewall, that is legacy firewall. So legacy firewall flow logic. Okay, so here in ASA firewall, what happens here? Packet will hit on the ingress interface. Okay, after that it will go and check these parameters. Okay, here this is little bit invisible. Okay, so here in writing you can see the steps here. what happens? While troubleshooting any firewall or any network device, packet flow understanding is very important. Okay, so here what is it? It is asking, it will receive the packet at ingress interface, okay, and put it in interface buffer. That is different thing. Increase the interface counter, run CRC check to get the header errors, perform IP reassembly for fragmented packets. Okay, after that it will check the IPsec. Okay, if there is a IPsec tunnel is running or SSL VPN is running and the client is requesting to connect to the any connect VPN, for example. So it will apply the decryption policy and the hashing and apply all checks of step one, just like this step again. And it will check the connection table. So what it is asking here, perform the lookup on connection table. If it's a new connection, then put this packet into connection setup state. If it's an existing connection, then provide fast path processing and bypass the connection setup state. Okay, after that it will go and check the routing table, translation table. Accelerate table means net table. This is the net table in a firewall here. Okay, and after checking the net table, it will check the ACL. Okay, after checking the ACL, if everything is good and pass, okay, then it will go for the deep packet inspection. Here, this is the legacy firewall, but they have the feature MPF, that is called Modular Policy Framework. That is the security feature in ASA firewall. Okay, it don't have any IPS or IDS engine and or any the email protection module. So it has only the MPF. Okay, so these are the security checks. After that, it will check the net IP header. Okay, and then IPS module. If there is firepower module installed in this particular device with ASA, so packet will go to the IPS module. Okay, IPS and AMP it will process. Okay, after that it will go to the egress interface. So in case of legacy firewall like ASA firewall, that is running with the IPS module or firepower module. So L3 processing will happen at the egress interface. Okay, so at the egress interface, it will perform the VPN encryption and hashing algorithm, and it will create the L3 header accordingly. After that, it will go for L2 processing again. Okay, and then finally, packet will go to the exit interface of the firewall. So this is the difference between the next generation firewall and a legacy firewall packet flow. This packet flow is very small. Okay, if you will go with the next generation firewall like Palo Alto firewall, packet flow that is very big. So you should keep in mind but initially what will happen at the ingress interface and what will happen on the egress interface. And this is the another traffic flow. Okay, so actually this is the main packet flow that is similar with that packet flow also. Okay, so but it is asking from here packet will hit on the ingress interface. From here it will check the L2 L3 networking. Okay, type of packet, high availability, configuration management and reporting. It will happen here. This is the ASA sorry Palo Alto firewall packet flow. Okay, after that it will go and check the port protocol. Okay, based on the app ID, it will check that thing. Firewall policy. Okay, packet will come here. Again, it will do this check. Okay, if these checks are okay, otherwise, if not okay, then go here, go here, go here, and go here. Okay, so if it is bypass,
Sushil, I have a doubt.
okay.
Once the packet has hit that ingress interface,
Mhm.
it's already done the check, right? That L3 networking. Then again, why it's checking that L3 networking HA configuration and the second stage. If you say that first stage, it is port and protocol ID policies, it is
No, no,
checked.
no,
Okay,
no.
that is fine.
See, for our understanding, they splitted this thing in multiple things. Okay, let's assume
Uh,
this thing is happening here only. Okay, now
okay.
here it is going like this, and then it is going like this.
Yeah. Okay.
Understood now?
Uh, Understood. I'm thinking again why it is
No,
going. I'm
no, no,
by
no.
seeing the diagram.
This is for our understanding only. They created like this.
Mm,
Okay, so suppose there is no firewall policy, na, it will bypass. Suppose there is no port protocol, simple IP address, na? There is no port, na? Source port, destination port, simple IP address. So it will bypass this also, na? This will bypass, this will bypass. Again, where it will go? So it will go like this. Okay, you understood?
yeah, yeah.
Okay. Okay. So we are running out of time, Lavanya. Do you want to extend or we can wrap up? It's up to you. Lavanya is here or not?
So we have a
Yes,
H4
Doctor.
time is there. We have to hand or they have to give.
That is what I am asking. If you guys want, then we can continue or we can wrap up for today and we'll start tomorrow.
Yeah, we'll start tomorrow.
Because next topic is very important. Um, uh,
Yeah.
TCP send
And
again.
if we if the topic is something in middle and we cut off here means that is difficult. If this topic is end, we can